Welcome 7th grade math students. We are going to take a look at lesson 3.7 where we're actually using real-world applications with our algebraic reasoning. So this is a homework assignment that we just sent home today. I only assigned 5 problems here, so we're focusing in on problem numbers 1, 2, 4, 6, and 10. So again, only 1, 2, 4, 6, and 10. You're definitely allowed to work ahead and do more than that, but those are really our focus for today. I'm fighting with my pens, like is often the case. So I'm sorry you get to see this in your video. All right, let's try that again. So let's go ahead, and we really want to remember those same skills we've been talking about. If we can simplify, we do simplify. We want to think about format. And if we can show higher level thinking, if we can show another way of getting there, that's really one of our goals as well. So number 1, Jeremy has 2 ropes. The longer rope is 12 and 5/10 x plus 17 centimeters long. And the shorter rope is 5x plus 0 and 4/10 w centimeters long. Find the difference in the length of the 2 ropes. Well, this is something that I think we could visualize pretty quickly. So I'm going to try this idea of maybe not so much a bar model, but maybe just kind of a stretch of a rope here. And I could show you that this is maybe my longer rope. I might label it L for longer, and I might call it 12 and 5/10 x plus 17. Well, it also talks about having a shorter rope. So I took care of this first piece, longer rope there, shorter rope here, and we want to go ahead and record that. So I'm going to draw a shorter stretch, similar to a bar model. It's just, I guess I'm visualizing a rope a little bit differently. So for that reason, we're going to call this 5x plus 0 and 4/10 w. All right, it does tell me to find the difference. So if I was really comparing these, it was talking about here how much more or how much less I see in this comparison. So I'm trying to find the difference between the 2 of them. So similar to a bar model, I've just used a comparison approach, and I want to show in math, using my algebraic form or reasoning, what that means. So it means I'm starting with a longer rope. I'm taking that longer measure, and I'm going to take away the shorter rope, the 5x plus 0 and 4/10 w. No, it's not a final answer, because if you think back to our previous assignment, I gave you lots of things to check for. So first, we have a visual model going here, which is really positive. So I want to see some approach from you that might be visual, like a second way of tackling the problem. The next thing I want to see is if we can simplify in any way, shape, or form. And in fact, you can here. There's subtraction sitting here, but this is actually subtracting a whole quantity. So to show that, we might change a minus to a plus, change the sign of next. And the only number that could really be sitting here is an implied factor of -1. It's kind of like telling me, I'm going to take this -1 and distribute it over the entire quantity. So we're going to give that a try. So let's go ahead and do a rewrite step here. This first quantity, that longer rope, it still has the same measure. That hasn't changed. But at the back here, this -1 is being distributed to 2 things inside. Well, -1 times 5x gets me a -5x. And next I have -1 times 0 and 4/10, which is going to get me a -0 and 4/10. And remember, that's a w here, so a variable term. Well, there was addition happening between these, so I'll show that addition happening between these 2 terms. And now we would ask ourselves, are we there yet? Right? It's kind of like kids in the back seat of the car for vacation. Well, no, you're not, because if you take a look, there are some like terms that can be combined. I see some x's that can go with x's. And then I see some constants, those are kind of unique. And the variable w, well, that doesn't go with much, so I'm giving it kind of a different code. So let's go ahead and combine our x's. I have 12.5x, take away 5x. Well, that's going to leave me with 7 and 5/10 x. It's going to be positive. I kind of followed that different sign subtract approach, and it's going to be positive because the farther number was positive. And next, I would just include the 17 as a constant, but I know I have to think about order here in a minute. So I'm wondering if maybe I want to write my variables first. Let's just see what happens here. I'll bring that down. That constant is sitting by himself. And the last thing I see is this variable term at the back, so plus a -0 and 4/10 w. Hey, this isn't bad. You won't get it wrong as long as you give it a good, strong label, but there probably is a better final answer. So what I'd like to see from you is to remember back to format. First of all, are they in ABC order? Is there anything I can do about that? Well, A, B, C, D, let's see. W comes before X in the alphabet, doesn't it? W, X, Y, Z. Oh, yeah, so I need to move this -0 and 4/10 w to the front. It's the first term. And next would come my variable X, so I'm going to show plus 7.5x. And at the very back, I would have my constants. They're usually last, but not least. This isn't too bad. But again, I now have followed this idea of format. I have an ABC order. I can't really change anything back to subtraction in this situation because I don't see that combination of adding the opposite that we look for. And we have decimals and a whole number here, or an integer situation, which is pretty positive. Not a lot to change. So I'm going to go ahead and label this. What was I finding? Find the difference. Oh, difference really means subtract, doesn't it? That's why we did that. In the length of the two ropes. So the difference, what is it measured in? I have a lot of students telling me the difference is this, but technically I want to know what kind of units we're using. So go back in the problem. Are we using meters, miles, feet, inches? No, we're using centimeters. So let's make sure that we label this appropriately. I have to see the units on your problems. So in your answer, bare minimum centimeters. Would it be better to say Jeremy's two ropes have a difference of this quantity in centimeters? Probably, but this is a good start. Okay, number 2. Here we're looking for the radius of a circle, and they talk about a radius of a circle, which I know, or I can remember back, and it also would be found in your planner page, maybe R9 or R10. They don't trust teachers with planners around here, so I don't think I have one to look it up. But on that page, you would see a circle, and it would have a midpoint or center point, and it would have a half mark here. It would show a line segment going from the outside of our circle to the inside of the midpoint. And this would be called the radius. It'd be labeled maybe R for radius, usually in lowercase. And underneath here, I know something. As I read this, they told me exactly that the radius is this length. So I'm going to go ahead and label that. I'm going to write 7n take away 21. That measurement goes right on my radius. Well, next they're asking me to find the circumference of the circle in terms of n. Oh, and they tell me that I get to use 22 over 7 as an approximation for pi. So I know I'm going to have to use pi in my formula somehow. So the real question is, what is the circumference? The circumference is kind of like the distance around, but instead of going around a polygon, we are going around a circle. And if you look in that planner, again, page R9, R10, I wish I knew for sure, it's going to show you a formula. Or if you look it up online, you're going to see something like this. Circumference equals 2 pi r. What that means is I'm going to double pi times the radius. Or it's kind of like doubling the radius, if you think about that. If I doubled the radius, that might also be known as a diameter. So another way it would appear is maybe take away the 2, take away the r, replace that with diameter times pi. That would be awesome if I knew the diameter, but I wasn't given that for this problem. So just food for thought. If you see this d in there instead, it's because 2 radii make a diameter. So that's kind of the thinking behind that. Let's focus on this one here. So let's go ahead and do some substitution, see if we can figure it out. So it tells me to use the 2, so I'm going to copy the 2 down from my formula. It tells me not to use pi. It tells me that I can use what? Oh, a fraction here. I can replace pi with 22/7. So there's multiplication happening here. I'm going to show that with parentheses right now. And the last thing it says is to use the radius. To show the radius, plug in the radius length. So if you look back at the problem or you look back at your picture for a description, you can see that we're really going to take the quantity of 7n, take away 21. All right, well there's no way this is done because if you take a look, there's multiplication happening here. And my rule with students today, we talked a lot about seeing multiplication or division. And when you see those symbols, it tells you to keep on going. You're not done yet. So kind of like shop till you drop, do the math till you drop. Please don't drop doing the math. All right, so let's see what we can do to simplify here a little bit. Well, I noticed something. Actually, I could probably take the first 2 pieces here and see what I get when I take 2 times 22/7. And if I were to rewrite that, I'd get 44/7. That would take care of the first 2 pieces of this product. But I'm not done yet because I'd have to take that in a minute times the quantity 7n, take away 21. And yes, I'd rather be working in pizza mode, but it looks like I'm kind of out of space here. So I hope maybe you're considering lined paper because this does take a little bit of effort and a little bit of work. Well, this 7n, take away 21 could be written as a fraction. How can I write any number as a fraction? Oh, I could write it over 1. So treating it kind of like a whole number would look. If you take a look here, I really could maybe just multiply straight across and see what I get. But I'm noticing something. This 7 that's happening here in this denominator, wouldn't he cross simplify with these two things that are in the numerator? That might be one way to approach it. So it's kind of like saying the 7 and the 7n in a moment will cross simplify. And then in another second, we're going to take the 7 because he's going to the whole quantity. It's almost like distributing division this time, isn't it? He's going to visit this negative 21 and cross simplify. So let's see if we can think about that for a quick moment. That 41, we're going to keep it the way it is. But this 7 in the denominator, it's really going to disappear. He's really going to divide or factor 7 out of this entire term. So if I'm taking 7 out of that entire term, oops, maybe I should get rid of my loops here. That was just food for thought. So if I'm taking 7 out of both of these terms, another way of writing it might be this. Actually, I just thought of this. This might be a really good idea. Oops, that wasn't the really great part of it. It's kind of like saying, I'm going to show multiplication here, and I'm going to show you that I'm factoring 7 out of this 2-term expression. So 7 goes into 7n 1n times, and 7 goes into 21 3 times. There was subtraction here, there's still subtraction here, and all of this is over 1. This might be easier to see at this point. If you take a look, I still want to simplify more. The reason why I factored out the 7, I don't often do that, but I wanted you to see that cross simplifying I was talking about. 7 really divides into both the numerator and denominator. So I can divide by 7 and get 1 here and 1 here. Now I have a little simpler problem to think about. I have 44 times 1 and then times this whole thing. If you think ahead, that's kind of like saying 44 times both of these terms. Well, what's 44 times 1n? It is 44 n's. And what is 44 groups of 3? Well, that'd be 120 plus 12 more. That could be 132. There was subtraction, there's still subtraction. And if you look at this denominator, 1 times 1 would just put a 1 underneath all of this in fraction form. I don't think I need to go there. In fact, I think I can call this my final answer. It's kind of like whenever we see that denominator of 1, we can take it away and treat it almost like a whole number. So in this case, we have a whole expression that we're dealing with on the top. Well, this thing needs a label, so I'm going to go back to the word problem and see what they were asking me to find. Find the circumference. Oh, circumference. It's kind of like a distance. So I'm trying to find the distance around. Well, what's this distance measured in? I'll go back. Is it feet, miles, inches? Oh, it is inches. It says it right here. So let's go ahead and label this. Notice I'm using parentheses to show that those inches really belong to both of these terms. Whenever we have 2 or more terms, meaning they're separated with operations of addition or subtraction, we have to make sure we're careful about our labeling. So we're using some parentheses here. All right, that took care of numbers 1 and 2. We're going to fast forward here and try to get you to numbers 4, 6, and 10 next, so that at least you have some good examples and some good help at home if you need it. So ratio problems, they seem kind of scary in here lately. That's exactly why I assigned it, because I want us to get more comfortable, and I think the more you try it, the better it gets. So let's dig in. Number 4. The ratio of the number of red ribbons to yellow ribbons is 17 to 6. I'm going to try to draw that out. So as soon as I see a ratio problem and I'm given the ratio in 2 terms, I can pretty quickly draw this. So I need 17 units. That should be 17. Might want to do a double check. 10, 12, 14, 16, 17 looks good. And next it says 6. So I'm going to try to make them about the same size. Pretty close. Now we want to think about and consider and label what this means. So I'm trying to show you this word problem in a visual way, because that's a good way to dig in and also really show your understanding. So remember, with the ratio, 2 things or more are being compared. In this case I have 2 terms, so we're comparing 2 things. The first thing they give me is the number of red. Ooh, red is the first term. So we'll kind of put this in a box and say, hey, red goes with 17. Let's go ahead and label this R for red. The next thing they compare those ribbons to are the yellow ribbons. I'll put those in a little circle here showing, hey, the second thing we're comparing is yellow, and it gets the second term, or that 6. So let's go ahead and label it. There we are. If we keep reading on, it says if the number of red ribbons is this amount, is 2m plus 5, how many ribbons are yellow? All right, well, we need to label this a little bit. We need to grab this 2m plus 5 and decide where to put it. Oh, red ribbons. It's all the red ribbons. All of these together get me 2m plus 5. If only I knew what 1 unit was worth. So this is where I like to tell students to chase the number, or today we get to chase the expression. This is the only piece of information we have to work with. So we need to decide how many units does it belong to. Well, it belongs to 17, doesn't it? So if I could figure out what one of these is worth, I'd be on my way to solving this ratio problem. Well, I have this total amount, and let's pretend it's 34. Well, 34 divided by 17 would get me 2. 2 in each little box, or each little unit. I don't have 34. Let's pretend I have 17. Oh, 17 divided by 17 boxes or units would put 1 in each of these little boxes or units. And that would help me solve the yellows, wouldn't it? But it's not 17. It's 2m plus 5. So we use the exact same thinking. We take that 2m plus 5, the total that we're given, and we split it by how many units it belongs to. Well, it belongs to 17 units. So this amount or quantity would fit in each of these little tiny units, wouldn't it? And if that's true for red, it's also true for yellow. Each one of these would be 2m plus 5 divided by 17. All right. Well, if that's a true statement, then I think I can answer how many yellow ribbons there are. I want to find this total, so I'm actually going to show you. This is the mystery piece. This is what we're trying to solve for. And I'm trying to stay in one variable because that's all we've worked with so far. So I don't want just one of these. I don't want just one box of them. I want 1, 2, 3, 4, 5, 6. Oh, 6 units of them, just like in the ratio. So to find more units, I need to multiply. Well, this is not a final answer because if you notice, there's multiplication, and we talked a lot today about simplifying if you see multiplication or division to be done. So let's go ahead and turn the 6 into a fraction so I can multiply. And also so that you don't accidentally distribute the 6 to the denominator, which we saw today. You don't want to do that at home. You don't want to do that ever. So in this case, this is 6 times this numerator. It's actually being distributed. 6 times 2m gets me 12m. And 6 times 5 gets us 30. There was addition between the two terms, so there still is. And let's talk about this denominator. It's still there. I have 1 times 17 gets me 17. Hey, I have one term, and I seem to have answered the question. Well, I was trying to find how many ribbons are yellow. That's the question, so maybe boxing it in here. I could answer this real quickly by saying yellow ribbons. Notice I'm not using parentheses on here. I could if I wanted to, but it's not necessary in this situation because really I only have one term. This is written as a single fraction. I realize the numerator looks a little complex, but it's still one fraction or one term. All right, moving along then, we just tackled number 4. That leaves 2 more to go. And I'm scared to give you too many answers while you're home, but I guess if you're feeling stuck, it's not a bad way to be learning. So number 6. The next thing we want to do is look at the hourly rates for a parking garage. So I have the first hour I see is $4. Each additional hour thereafter is $3.20. And then it goes on to talk about Robin. Robin parked her car in the garage for Y hours. How much was her parking fee? Oh, I'm going to try a model. I'm going to try to break this into something that's meaningful to me. So I don't know about a bar model. I could, but I'm going to try to think of a timeline instead. So it's kind of like a timeline. So if I started, or I was Robin parking my car, the very first hour is going to cost me how much? Well, this is for 1 hour. I'll write that. That would cost $4 from the table. That's what it says. Ooh, what if I stayed for a second hour? What if Robin's car is there for the second hour? So we'll write second hour here maybe. Oh, how much would that cost? Over there it says it costs $3.20. Well, what if that continued? What if there was a third hour? Well, that would add on another $3.20. And this pattern would kind of continue. So how do we turn this into Y hours? Well, if I think of this whole timeline as being how many hours Robin is there, Y hours, I probably could break this down pretty quickly. Well, I know no matter what, I'm going to have to pay this $4, right, for the first hour. So that's an instant. That's $4 magically. And I'm not sure if you need the $ sign on there right now, but I did. So we'll just roll with it. Next up. Well, how many more hours is she staying there? I don't honestly know. But in this situation, I wrote down 3 hours. And how many of those 3 hours would be charged $3.20? Just 2 of them. That's interesting. What if I did another $3.20 for another hour, like a 4th hour over here? Just kind of thinking, how would that work? oh, if I'm there for 4 hours, I only get charged $3.20 for 3 of them. I hope you're noticing a pattern here, but I'll try one more time. What if I'm there for the 5th hour? How many times do you get charged $3.20? Well, you don't get charged that for the 1st hour, but you get charged that for the remaining hours. You get charged that for 4 of the 5 hours. Oh, I'm noticing something. Every single time I look at this $3.20 charge, it happens for 1 hour less than Y, or less than the total. So in this case, I want to make sure that I add on $3.20, but not just as a total. That depends on how many hours I'm there. So in this case, I'm going to write, well, the total was Y, but every single time, I'm not charged as many hours as I'm parked there. I'm charged 1 less hour. So I'm going to show takeaway 1. All right, this is not a final answer because I noticed there's some distribution. So we can go ahead and distribute here a little bit, see what happens. I'm going to take those dollar signs off just to make my math work a little bit quicker. I'm going to get 3 2/10, or maybe 3 20/100 Y. And I'm going to be taking away, or adding the opposite of $3.20, or $3 and, I didn't do that last 0 on there, did I? There we go. 3.2. Hey, this would be great. It's not a final answer because you need to check your rules. Well, we're looking for variables first, yes. But before I can even go there, is there more I can simplify? Oh, look, I have some constants. Can't those go together? But be careful. This 4, it's a positive. This 3.2, not so much. You might want to change a minus to a plus, change the sign of next. So we're digging in, we're grabbing our integer rules, we're making sure that we recognize that this is a negative quantity, so that I'm going to use my rule of difference, sign, subtract, or 4 take away 3 2/10. If we work off to the side here, let's see, 3 2/10 isn't far away from 4. It's only 0 8/10 away. And would that be positive or negative? You want to ask yourself. Looks like the positive number is farther than the negative, 0, so we'll keep it positive. And next I have this 3.2y. This isn't bad. It's not a final answer. Again, this could be rewritten. In fact, we want our variables to come first, so I'll call this 3.2y, or 3 2/10 y, probably better to say. And I'm going to add 0 8/10. That's just a constant at the back. Is there anything more we can do for formatting or simplifying? I think not, but this is a word problem, so I want to give you words back. And notice I'm using parentheses because we have multiple terms. 2 or more terms use parentheses. So how am I measuring this? What did I find out? How much was the parking fee? Please don't say the parking fee is this, because that's not enough. But you could tell me the parking fee is this, and we're measuring in dollars. Had a question earlier today about putting the dollar sign out front instead. That's okay, as long as you have these parentheses happening. Had a question today about why didn't we write the word cents next to it? Well, we also showed how that would look and mean something differently. If I had 3 2/10 cents, it's kind of like saying I'm going to multiply it times 1/100th, and that definitely changes the meaning. So again, this is dollars, and I can go back to the original problem to see how are they measuring? Oh, dollars are my units. All right, last but not least, number 10. We kind of skipped some good ones in here, but I give you number 10 just for a challenge. Let's see if I can get there now. All right. So number 10 is a ratio problem. Oh, coincidental. I like these a lot, and I hope you're starting to understand them a little bit better. The ratio of the mass of bottle A to bottle B to bottle C is 7 to 5 to 11. Whoa, lots of information. Not only is this a ratio, I'm comparing 3 things, A to B to C. So I'm going to label this. This is A to B to C. That way I know the 7 belongs to the A, the 5 units belongs to the B, and the 11 units belongs to C. It says the total mass of bottle A and bottle C is this. So it's like saying I'm going to draw out the ratio of bottle A and bottle C for a quick minute. I'm not sure if that really goes with part A. Not really. So I think I'm just going to draw it over here for a quick minute. So it says bottle A and bottle C. We're going to find their total mass. So if A has 7 parts, 1, 2, 3, 4, 5, 6, 7, and C has 11 parts, 6, 7, 8, 9, 10. It tells me that their total mass would go with both of these bar models. So I want to show that that's a total of 2x take away 9. And it's measured in kilograms, but I'll kind of save that for my labeling in a minute. Well, this is kind of helpful because I know I can chase the number. I can chase my expression in this case. So the only thing I know is this 2x minus 9 goes with a lot of units. How many units? Well, what's 11 plus 7? 18. So if I could figure out what one of these little boxes is worth, I'd take the total and I would divide by or split it into 18 little tiny parts. Ah, every single unit, every single one of these is a quantity of 2x minus 9 divided by 18. All right, so how am I going to use that information to help me? Let's look. I'll read the second sentence now. I kind of got carried away with my picture, didn't I? So the total mass of bottle A and bottle C is this in kilograms. We're ready for part A. Express the mass of bottle B in terms of X. Oh, I left out bottle B. Could I draw that here? It's a little out of order, but would it be okay to do? Could I draw you 5 units really quickly? Probably. I could ask you, what's total mass? Well, if I already figured out what every single unit is worth, in this comparison or ratio, every single unit is going to be worth that same amount. So how many units am I talking about? Well, if I look at bottle B, it looks like it has 5 units. So I'm going to want 5 of those little tiny units. Well, each little tiny unit, if you look back, was worth 2x minus 9 over 18. So 2x, take away 9, that quantity divided by 18. Oh, I almost have an answer. You cannot call this a final answer because I noticed something. There's a distribution sitting here, or a multiplication, depending on how you view it, and we can take care of that right now if we turn 5 into 5 over 1, like a fraction, and distribute. So let's see what we're going to get. 5 times 2x gets me 10x. 5 times 9 gets you 45. And if you notice, there was subtraction, there's still subtraction. Or if you change the minus to a plus, change the sign of next, there's another way to show that. Next up, the denominators. 1 times 18 is 18. I don't think Math and Focus calls this the final answer, but I would say because we're in one term, it's not a bad place to be. I think they actually split it into 2 terms, which is okay. There's another way to show that. But if I were to stop here, I just have to think about how are we measuring the mass of bottle B? What is its mass? Oh, I'm measuring in kilograms. So this is an okay answer. And when I mentioned there might be another way to show it, kind of out of space here, but I'm going to head this way. Another way to do that might be to break these into 2 different parts. This is the same as saying 10x over 18, take away 45 over 18. And I think, again, I talked to you about trying to be flexible in your thinking today. Math and Focus might do this, and we might see this as a final answer, maybe in a multiple choice question or something like that, because you can simplify a little bit. Take a look at 10 18ths. Don't we divide the top and the bottom by a common factor of 2? Oh, I could. It looks like I'd get 5x over 9. And another reason to do that is because look at the second term now. Wouldn't it also simplify? What divides nicely into 45 and 18? I can think of 3. 3 goes into both. Is there anything bigger? Oh, 9. 9 is the greatest common factor that goes into both. 9 goes into 45 5 times, and 9 goes into 18 twice. Notice there was subtraction between my 2 terms. There still is. So this is another possible answer. If you decide to do this, you have to have those parentheses, and you'd have to call it kilograms. I noticed a moment ago, I didn't really need those parentheses. I guess I'm just in the habit of doing it. Those kilograms would belong to the entire fraction that's sitting here. All right, we're ready for part B. This is really a substitution. It says they know exactly what x is going to equal. So in a moment, I'm going to take x right out of my problem and replace it with 15. Okay, we call that substitution or evaluation. We're evaluating the expression. Find the mass of bottle B. Well, if bottle B's mass is sitting here in algebra form, I'm just going to replace that x with 15. So let's do a rewrite. I'm going to keep the 10 because it's in my expression, but I can change the x to 15. Notice I have to show you multiplication here. So either a star or an asterisk, or a dot, something that says multiplication, and take away 45. And that's all written over 18. Oh, you can simplify this. You can actually get me to a number answer now. We took out the algebra. We are evaluating. So 10 times 15 is 150. And I'm going to take away 45 from that. And that's all over 18. You're almost there. Actually, I could be using equal signs. This is not just an expression. This is actually an equation. I'm going to actually get to a numerical answer. And 150 take away 45 would leave you, let's see here, 105, looks like. 45 plus 5 is 50. I need to get back up to that 150 mark. Yep, that'll work. And all over 18. Well, this is messy. I wouldn't typically report my mass to you in this format, so how else could I change it? Could I simplify a little bit? Well, if you notice, it looks like 3 might divide into both of these numbers. 3 goes into 10 3 times with 1 left over, so 3 goes into 15 5 times. 3 goes into 18 6 times. This is a possible answer for kilograms. It's not bad. I don't think anything else divides nicely into that. So this is one possibility. Maybe you prefer to write it as a mixed number. So maybe you say, well, I know 6 goes into 35 5 times, because 5 times 6 is 30. When I take away those 30 small pieces, I'll be left with 5 extras out of 6 kilograms. This is another possibility. So we've got a couple good answers sitting here. And someone else might say, no way, kilograms? Well, that is a scientific measure in the metric unit. So in that case, you're probably going to turn it into a decimal. And you'll just want to be sure that that 6 will terminate, or that you start to see repetition when you try to get it into decimal form. So just a last thought for you, if you want to take this to a more scientific approach, kilograms, yep, they are a metric system, which typically would be decimals, not fraction format. But I'm not going to emphasize that at this moment. We're going to let you go with either of these 2 answers as possibilities. And if you want to show me what you got as a decimal in the classroom, I'll be totally awed and impressed. So that takes us through lesson 3.7. This is our wrap up for chapter 3. You are not expected to be a master with these things yet, but good exposure so that you're kind of prepared to try it in a couple different ways. Maybe with a visual approach, turning it into an algebraic expression, and simplifying as much as you can, whatever you can.